So, Lauren, I think this is your first lab, is it?
Yeah. I don't really know exactly what I'm doing here. I just like came to check it out. And we were talking in the comms call that you guys are doing CAD with chess games,
Yeah.
and I wanted to see what that was about.
Yeah, exactly. We're trying at least. We tried last week and it turned out to be more difficult than we anticipated, so we're back this week.
Cool.
Cool, cool. So I usually give it a few minutes for people to trickle in, but sometimes some weeks I'm more ambitious than others, so this week I definitely want to get a lot done, so I'll probably jump into it pretty quick here. So there's this kind of ritual that let me share my screen. Let's see. So the more participation, the better. Lots of people come and just watch, and that's fine. But sometimes there's some interactivity, and so to kind of spark that off, what we do is we have this. So I get everyone at the beginning to go to the labs channel in Discord, and from there you can find the main workspace. It's a Notion doc. And there, you'll see the attendance sheet there. It's the second link. And this is just a chance to have some fun with emojis in the morning. So let me insert lab 13. And so Lauren, if it's your first lab, just go ahead and add a row with your name, and then all the sort of information is optional, but anything you want to post in there. This is making kind of an interesting data set that we can analyze at a later lab. We can do statistical analysis on emojis. um, so let's see. Oh yeah, so pick your favorite emoji and just use that or any symbol you want for your attendance. Awesome.
Hello, Ryan.
Hey
How are
Tonga,
you?
great. Nice to have you
Yeah,
here.
so, yeah, sorry for being a bit late. Can you hear me okay?
Uh,
Or
yeah, the audio's a little it's not so good. Sounds like you're on a train, at least on my end. Let's try again. Hey Jake, nice to have you here too. I was just
Metal talking engineering, train to hell.
all right.
What are you doing?
Rock and roll. I was just asking Lauren if she knew you. I guess you guys are both in Costa Rica, right?
No, okay, no, hi, Lauren. No, just because we live in the same country doesn't mean
Oh yeah, I
we
get that all
talk.
the time as Canadian. Oh, you must know Steve.
You must know this guy.
Yeah. Well, just checking.
Hi,
Doesn't hurt.
Lauren.
Doesn't hurt to check.
Yeah, that's fine. No, it doesn't.
No, but it's not unreasonable to suspect. Like all the hippies
Yeah.
around here know each other.
Hey, that's what I was thinking. Okay. So let's get. Okay, so I'm gonna make a bit of an agenda. So let's check. There's been a discrepancy. So in some places now these labs are out of sync. This says 14. The attendance says 13, but that's okay. So this is. Oh, I need to edit. Continue. So we just.
hey, why did
Hey.
it? Sorry. And now I'm on the phone, but I can't see the screen. So I think the best option I have is to be on the screen and communicate by typing on the lab channel if there is one.
Can you use your phone for audio and your computer at the same time?
Yes, but not Discord. Like not when I get into the channel on the phone, it gets out in the computer. So
Oh, really?
unless you use something else to share the screen, but it's
I can,
yeah.
yeah, I can, if you want to watch my stream, I can also stream. So you
Yeah,
can,
if you stream, then I can do it.
yeah. It's actually higher resolution on Twitch, so. Yeah, let me know if it's working. So let me send the link in the. I'll just DM it. Tonga. Okay. Yeah, let me know if that works. So we're gonna take the pre-built Python ChessPy game that me and Tonga found last week instead of trying to build it from scratch. So that'll save us some time. Um, we're gonna just plug that into CAD and see if we can get that working. I think it should go all right. After that, we're gonna see if we can visualize the chessboard with HoloViews. So we'll be able to sort of play back the simulation and see how it went. Oh yeah, and this is just gonna be using players will take random actions. And if we get all that working, the simulator and the ability to visualize the board and the games that play out, then at the end we can try to shoot for the moon and try to plug in some AI. See if we can get it learning. Okay, so again, pretty ambitious. Let's see. I'm sure we can get the simulator working this week. So, and for anyone who wants to track, the code on this is GitHub TE Commons /Tech Lab. So last week we were in lab 13, so I'm just gonna copy that over into a directory lab 14. Jump to TEC labs, cd TEC lab. Okay. Okay, so let's make directory lab. So we're in the GitHub repo here. So let's make directory lab 13, oh, 14, lab 14. Okay, actually copy. Copy lab 13 into lab 14. Lab 13, no directory. Oh, it's lowercase. Lab 14. Okay, and activate our virtual environment. Let's see, virtual fish, activate. TEC lab, do we have something like that? TEC lab, cool. Alright, and into Jupyter. So let's see what we had from last time. ChessCAD. Okay, how can people see this?
Yeah, yeah, yeah.
Yep.
And the resolution is higher on on Twitch, so you guys always have that option. I think that's pinned in the labs channel as well. Let's check that. Oh, it's not. Okay, let me higher resolution than Discord. Oh, I can't pin messages. Jake, are you admin?
I'm sure I can pin messages.
Yeah, okay, yeah, I can too, Griff. Yeah, we can.
No, you go for it. You go for it, Jake. I'm
Okay.
actually non vanilla Saturday.
There's someone's got an echo going. It's kind of neat actually. It's like a loop. Jake. Okay, so no module CAD. I don't know what virtual environment we were using. But anyways, we should be able to just pip install CAD. Okay, let's see. Okay, that seems to work. So the last time we were setting up chess manually. Hey Jake, can you mute? Okay, so we had created the board here with uppercase letters. Jake, do you guys hear that? Oh,
I was muted.
oh, maybe
Yeah, I
it's.
actually don't. I don't hear an echo.
I think it's on. Oh,
Me
it's
neither.
it's literally because I have Twitch open. Okay, thanks. Sorry, guys. Um, yeah, so just a little refresher. Last time we sort of manually created this data structure to represent the board. So we had uppercase letters for black pieces and lowercase letters for white pieces. We were just making this up on the fly. Today we're going to skip all that. I think I'll just make a new notebook here. Call this ChessCAD 2. ChessCAD 2. And we're going to try out this recipe that Tonga and I found. So if we just look up chess in Python, we found something quite nice. Chess program for Python. And I think it's just one big file. So I'm just going to grab this and bring it into our virtual environment. It's only 240 lines. Let's see if it works. Okay. Cool. Cool, this looks so awesome. Chess program. Enter moves in algebraic notation separated by space. Okay, Tonga. What is algebraic notation?
Yeah, the one I told you, A, B, C, D. I don't know why this is like from the top to the bottom. Uh, it's usually, and also the pieces are in the left and in the right. So it's a weird way to see a board.
I
Um,
wonder if we could fix it. Where's like, oh, print board. So for item, okay, I self.gameboard.get ij print string. Okay, so what should it look like? Where should this, is this 1, 2, 3 and ABC, is that correct? If we, let's say for example we switch white, so we turn the board 90 degrees clockwise, so that we're the white pieces. Um, then are these, no, then these should rotate as well, is that right?
yeah, the numbers should go from bottom to top, and the letters from left to right.
Okay, so the numbers, okay, so we're gonna rotate this board 90 degrees, and the numbers should go, both of these should be go backwards, I think. Let's try that. Okay, so if we're gonna rotate the board 90 degrees, so what we're doing now is we're going for IJ in 0, 8 for our game pieces. Oh, okay, so it's here. So let's say I is 0 and J is 0. Then we're getting the rook. But we actually want this rook to be here. Okay.
Like if white pieces were on the left, the board would be okay, but only that it would be flipped, but it wouldn't interfere with the solution. Like, but the black pieces are on the one. That is weird. Like on
Okay,
the
let's
one and two.
so if we flip these, oh yeah, if we flip the pieces. Okay, let's see if we can do that. So gameboard.get ij. So we want to flip on the, like, I is the row and j is the column. So we actually want the opposite. So and this is going from 0 to 7. So let me just try this. 7 minus j. See what that does. Um, hmm. Let's try this. Um, Did something happen with our kernel? Oh. Hmm. Okay, so that seems to have worked. Okay, so we've, Tonga, we flipped white and black. Now, should we rotate the board?
That would be optimal. Yes.
Okay, so let's see if we can rotate it counterclockwise. And these indices are correct now? If we
What do you mean?
so it goes from 1, I mean white starts on 1A and the letters and numbers are ascending.
Yeah.
Yep, okay. Let's see if we can rotate the board the way the board is drawn. So do you guys see what I did here? I just, since these indices are going from 0 to 7, so remember in Python we have the range. So I and j, which is how we index the board, are going from 0 to 7, because we get up to but not including 8. So if we actually change j to 7 minus j, then instead of going 0, 1, 2, 3, so when j is 0, this value is going to be 7, and then as j increases, this will decrease down to 0. So we've just reflected the columns. Now, if we were to rotate, so we want this 0, 0 piece to actually be here. So instead of it being showing at 0, 0, we want it to show at 0, 7. So we want to show 0, 7 first. Oh, so I think I might just have to... No, and it's not a reflection. So we should show 0, 7. Wait. No, we want this piece to go here. So we want 0, 7 to be shown first in 0, 0. And then we want 1, 7. So I actually have to write this down on paper. So I don't know if everyone's following me here, but right now this rook is in position 0, 7. And we want it to be displayed in position 0, 0. Because we're doing this 90-degree rotation. And then this knight is currently in 1, 7. Or you could say B8, but in the computer program I'll stick to the computer indices, I and j. So this is at 1, 7, and we want it to be at 0, 1. 0, 1. Because we're 0 indexing. And it's always rows first, so we count the rows and then we count the columns. So...
Can't you try to transpose the matrix, maybe?
Well,
or only the headers?
That's a pretty cool idea, but it's not a matrix. It's just being printed sequentially. I mean, it looks like a matrix, but it's not represented as a matrix in its data structure. It's not like a NumPy array kind of thing. So, how to rotate this board? Let's see. I'm trying to think. Like,
It's not necessary.
okay.
To...
Let's not get stuck on it. Thank you, Tonga. Okay, let's just see if it works first of all. So let's put in a move algebraically. So Tonga, can you think about what we should type here? So let's say we're white and we want A2, or do we type a like P for pawn, or how do we do this?
No, the pawns you don't say the letter, but I am seeing the king is on D1 and it should be on E1. The white king. Like on black side is okay, but on I think maybe it was already because the kings should be on the same column usually, like always.
Mm.
So I don't know if the board was already.
Oh, let's just double check that. So before we had this. Yeah, and it gets this kind of weird glitch where we can't, let me just rerun, like, I think it's from the user input. It gets a little glitchy when we rerun it. Let's see, stop.
Do Jupyter notebooks have like are prepared for less code at once, or they don't care?
Oh yeah, it shouldn't be a problem. Like, it's not like too much. Do you mean it might be too much code in the notebook?
Yeah, in one cell maybe. I
No,
don't
it
know.
shouldn't be a problem really. Um, oh, this is going pretty inconvenient. So this is why I want to visualize the board with hollow views. So we might try that first so that we can not have to render it this way. So I wonder if we can actually change the print. So this print board. So we're going to get a game board object. So let's just take a let's not use that let's change that render function. So let's see if this works. And we have our game object, but when we instantiate our game, let's see where the game is defined. Here, and here's its main function. It's in this infinite loop. So while true, print the board. So let's like deconstruct this. So let's take this and I'm gonna comment this out and grab this functionality and bring it down here. So this way, and let's just take out this infinite loop here for now. So this is like printing the board. So we should be able to say self equals game. Okay. I'm just gonna like something in there is blowing up our Jupyter notebook, but we're gonna find it and remove it. Wow, I can't even kill this. It's so interesting. Okay, there we go. It's trying to call main. From what line? 16. Oh, and it's initialization function. Okay, okay. So let's just remove that. There we go. We've got it by itself. Okay, cool. So now we can see what what functions it has. So can see king. What does that do? Cool. So there's all these different functions we could explore. Is check. Oh, not sure what that's doing exactly. So we could
If
really
I had to guess, yeah.
I was gonna say
Yeah,
we
it's
could really
checking.
enhance this. We could make a pull request on this repository with a lot of upgrades. We can add for example, we could add doc strings. So what were you about to say, Tonga? Is check. Let's see.
Is checking if a move is checking the king.
Oh. Ascertain where the kings are. Check all pieces of opposing color against those kings. If either get hit, check if it's checkmate. Cool. So we can turn that into a doc string. And so now, if we put g.isCheck question mark, then we get the doc string here. So it's always good to include doc strings in the code so that developers can get the inline documentations. So we can add doc strings to all these functions actually. So what else do we have? Game board, cool. This is gonna draw, I think. Dict, not call. Okay, it's just this. Oh, so this is the data structure. Okay. So it just has each piece and where it's located on the board. Okay, that's kind of neat. G dot player's turn is black. Okay. And G dot what else we got? Place pieces and parse input. So place pieces. Okay, so it sets up the board, I guess, for iron range 08 pawn. So it places the pawns, and then for each of the objects of rook, knight, etc., it places them as well. Interesting. And then it reverses at the end. Huh. Okay. So let's see what we can do with this game board. So it has this print function. Let's check this print function again. Print board. So let's read this. The game class contains the following members and methods. 2 arrays of pieces for each player. An 8x8 piece array with references to those pieces. A parse function which turns the input from the user into a list of 2 tuples denoting the start and end points. A checkmate exists function which checks if either players are in checkmate. A check exists function which checks if either players are in check. A main loop which takes input, runs it through the parser, asks the piece if the move is valid, and moves the piece if it is. If the move conflicts with another piece, then the piece is removed. And checks is checkmate, and if there is a checkmate, the game prints. Let's just do this. If the move conflicts with another piece, that piece is removed. If is checkmate is run, and if there is a checkmate, the game prints a message as to who wins. Okay, let's just grab this. That's super handy. We're going to need this to plug in everything to the simulator. Let's see, 8:30 already. Okay. Good. So we're starting to understand this code base and the actions that we have available. That's what's key in running agent-based simulators, is knowing what the actions are. So let's see if we can like kind of manually walk through a game here. So we create a new game, and we have the game board. Let's check our print function that we were looking at. Did we grab that? No. Okay. Let's check our print function. I plus 97. Oh, this is to get the ASCIIs. So I'm not sure if people are familiar with ASCII charts, but this is the standard way of embedding text on a computer. And so you have a binary code for each letter. So like A starts at like 65, and the letters run down. But I think there's actually chess pieces in ASCII. I don't see any right here, but let's see. It's saying char I plus 97. Those might just, oh, those are just letters. Oh, this is just converting numbers to letters, actually. Because if anyone's written C code before, you'll remember, like, the char. You have to, and strings of chars are how you write words. So let's say I equals 0. Okay, so this is just A. And this will go up to H on our board. Okay. So let's try print board, and we made a new board here, which is G. So if we go G, okay. So we're getting this now, good, and it's not crashing our Jupyter notebook. Okay, great, we're making progress. So before we figured out how to reverse these, so we go 7 minus. Okay, so that reverses it. Okay, so now we can print our board on demand. This is pretty cool. Now let's see how we can walk through a game. Like, we need to see how what's running here. So first it prints the board. It takes start position, end position equals parse input. So let's see what parse input gives us. So we have our game board g.parse input. Oh, okay, this is that function. Okay, that's the one that's, we're not going to use that. We're going to simulate the input. This is the one that's breaking our Jupyter notebook. There. Okay, so it wants a start position and end position. We just need to know. Oh, okay, so let's try this. G.gameboard, and it wants a start position, which is A, or like a number. No. 8. Wait, key error. Oh, it wants one of these. Okay, so we go like 0, 1. Okay. So I guess this is what it was expecting, a pair of indices for the input. That's what it's calling algebraic notation. Kind of confusing. Tonga, I think we can write the best Python chess repository. Maybe that should be a long-term kind of side project that we take on. I think we could do much better than what this is.
Yeah, but I think we should research more before, because there is already supercomputers. I don't know if they are open source, but they might be. So, yeah.
Oh yeah, do some more research. Yeah, this is the first one we found on GitHub, but it's a good exercise. Okay, so we now know how to get a target. So this is what they're calling target, and if it exists, yeah, it says found. So, oh, so a target is actually a an object. Target dot. So this is like a piece, and it has all these functions. So available moves, cool. Requires 3. Okay. Available moves, and so we need to know where it is now. So that's 0, 1, and our game board G. Let's see, G.gameboard, I think. .gameboard. Cool, so this is the only move available. So it looks like it's not taking into account, isn't there a move where you can like move your pawn 2 at the beginning?
Yeah, you can move once or two.
So
Squares.
this simulation's not taking that into
But
account.
only at the beginning. You're only allowed that option at the very beginning. to move 2.
Okay.
Like not in the first move, but in the first move of each pawn.
So we should be able to check its color as well. White. Okay, so this is a white piece. And we get its available moves. Interesting. Okay. So if let's see. And
Wait. No, I was going to say I'm waiting for catcat.load config, catcat.run,
okay,
and
let's try it. Let's just bring. Probably don't need that. Let's bring this in. Okay. So again, I don't know if we need any system parameters really, but maybe we'll find out. But then this is where it gets interesting, the initial state. So really the initial state, I think it's just, for now, because everything is embedded in the game. So let's just say game is G. And sure, let's this is embedded in the game, so we don't need that. Let's try this. Okay, so we have G as our game state, and we're tracking if it's finished, who's the winner, what the move number is, and what pieces are captured. So now we have to define a policy. So standard CAD goes something like this. So let's just say progress game. And these are all the parameters or the inputs that we get to our policy. So the system parameters, the current substep, the history of the game, and the most recent state. So what we're going to do is we're going to grab the game equals previous state game. So now we have the game in our simulation during a step. And we're basically going to do what happened here. So now we have to get moves available. So this is the interesting part. We're turning, because before this thing had input that's meant to be from a human, but now we want to simulate. So let's see if we can start off by choosing randomly. Like what I want to do is, based off whose turn it is, get the set of available moves. So can we do that? Get the set of available moves. We can check for each piece. Yeah, let's see if we can enumerate available moves. So there's not that many. So let's go game dot, what was it when we saw all those pieces before? Right here, game dot game board. Cool. So we have game dot game board, and we're going to have, it's going to be a certain player's turn. So we're going to say game dot player's turn black. Okay, now this is where it gets fun. So we can say, let's say like position piece for position piece in g.gameboard if, okay, now I want to filter for the current player's pieces. So let's go g.gameboard 0, 1. That's going to give us a piece. And we want to get the color, I believe. Okay. So we're iterating through all the pieces on the board. And we want to say if piece dot color equals g dot player's turn. Player's turn. Piece. Int object. What do you mean int object? G.gameboard. Let's see. Oh, dot items. So we have a dictionary. So gameboard is a dictionary. So to get all of the key and value pairs, we have to use this dot items. That's a standard function on a dictionary. Okay, so now in our simulator, we can grab all the pieces available to the current player. So, although this is really interesting, look at this. It says current player is black, and it gives us all the white pieces. So, or, yeah. I think we're finding a lot of bugs. That's okay. This'll work. Or we could say does not equal. So that we get all the black pieces. So these are pieces available. Now for each of these pieces, let's call it current player's pieces. We want to, for each piece, we want to check all the available moves. So this might kind of blow up computationally, but let's see. So again, let's say for position piece in current pieces dot items. So this allows us to iterate over this dictionary. And then we can do something similar to what they do with the printing. We can just loop over the board. So like this. I don't think we want to print all this. Maybe I'll keep this a bit simpler. So I'll just say for I in range 0, 8 and for j in range 0, 8. Then we want to check. So for example, I don't know if there'll be a faster way to get all available moves, but we just want to, let's say available moves. Available moves equals a list, and there is a function on the piece itself. So I thought we had an example of a piece somewhere, maybe not. So it's like, let's grab this pawn. Current player's pieces 0, 1 is the pawn. So dot available moves. Oh, this might. Oh yeah. So then we want to go piece dot available moves. No, okay, so we don't need all these loops. We just need to know. It's way easier than this. So it's piece dot available moves. I think it's gonna be like this: position and game board, which we are calling g.gameboard. let's just print this. I thought this worked before. Let's just try this again. Piece equals current player's pieces. Yep, this is what we want. So this is a piece. Oops. So we can say our piece equals this. Piece, okay. Oh, I think I spelled available moves wrong. Piece dot available moves. Yep, this is camel case. Cool. Okay. So Tonga, do you see what this is?
I see a lot of moves, it seems. I don't know.
Yeah, so we're checking, so we've been able to filter for a current player's pieces, and now we're just looping over all of those, and for each one we're checking the available moves. So we can see here that these are all the pawns, and these are the knights. So this is the action space available to our agent in the agent-based simulator. So we're making some progress here. So at each step of CAD, our models are going to be able to run this function, which is like get available moves, and they'll be able to pick one of these moves. So we're going to concatenate these into a list. So we're going to say available moves dot append each of these available moves. Oops. Why did it do that?
It's going to be harder because it doesn't say which piece it is moving. When two pieces can go to the same square, like usually when you play chess, you write which piece are you
Oh
moving
yeah.
unless it's a pawn.
Yep, so we can do
And
that. We can go piece. So like this. Oh, but we want to know its location, maybe?
it's now it's much better. It's not necessary.
Cool. So this is the action space available to our agents. And it was just weird. I was just trying to save that. Oh, I know why. Okay, we need to go like take this out. This is called scope.
I have a question. When it says 0, 2, uh, that is the index of the square where it can move.
Yep.
Because the pawns can go to 2 squares.
Yeah, that's a missing feature. That's a missing feature in this simulator. So we'll have to live without it. Later we can actually add it, and we could make a pull request to this. Actually, we could fork this. We can fork this chess.py right to TEC. I think I'll just do that. And then if we want to upgrade it later, oops, it forked it to mine. It didn't give me an option. But yeah, we can fork this right to TEC and maintain a version of it. Because we could definitely upgrade this. So let's see, now we get available moves. Okay, good. So we have like 9 minutes. I think I can run a CAD simulation. Just gonna, let's see. Oh, there's a bit left to do yet, but I'm gonna make a function. Get current players available moves. And this basically needs the game board. Let's see, it takes like current player and game board and G, I guess. And it's gonna do this. And it's gonna take current player, which is a color. So we need this. Current player's pieces equal this for G and game board, if piece.color equals g.player's turn. Oh, so we don't even, I think we just need this. G. Get current player's available moves of G. It doesn't return anything, so let's go return available moves. Cool. So now we can, if we want to just get a simulator going, we can numpy.random.choice, and we can pick one of these, and we get a random move. Oh, these are, okay, so there's multiple random moves. So this actually just picks a piece, and then we go dot values and of 0, oops, values. Okay, getting kind of confusing, but
Maybe another random choice between the moves.
exactly. So this is getting the piece. So let's say random piece equals this. So we can see the random piece, and then random piece dot values, and I want this, I think, as a list. Yes, and 0. So there's a lot of indexing here, but and then I think I want random numpy.random.choice. Oops. Must be one-dimensional. That's annoying. Really? Seems odd. A equals this. No. Let's just Google this. Python. Maybe this will work. This is annoying. This is a list. We should be able to choose a random. It's complaining because it's a list of tuples, so it thinks we're passing it a multi-dimensional array. That's just a weird sort of oddity. Sometimes we hit these things. We're so close. My clock is glitching out. I don't know what time it is. It's just because this is a tuple. I could just turn it to a string. And then we can do that. And then turn string tuple to tuple. Yep. No. Oh, wait. Literal. Python get literal. Stack Overflow. saw this the other day. Okay, I want to turn this thing back into Python string list into list literal. Yes. ast.literal eval. Of this. Alright, so that's a weird hack because we hit a bug where we can't take a random choice because it thinks we have a 2D array, but anyways, we solved that. So what we have now, I know this looks like a mess, but if we put this all together, we have the ability to sample random moves that are available to us. So we get a random piece, and then we get a random move of that random piece. So let's just say moves, and we select now a random move. Let's hope this works generally. Yep. Unless it's empty. Wait, how could it be empty? What's our random piece here? Random piece. Why did it select an empty? Oh, get. Oh yeah, some of these are empty. So we need to select the non-empty ones. So we can actually do another. So piece for piece in all of this if piece dot values. Does that work? No. Oh, yeah, maybe. No. So I might be over time. What time is it?
You're 45 seconds over.
Dang. I think, well, thanks for joining, everyone. I think I'll just keep going on this for anyone who wants to stick around. I want to get this simulator running.
Thank you, YGG. I have another call, but always amazing.
Thanks, Griff.
Bye, guys.
Thank you, Sean.
Thanks, everyone.
I can
Bye-bye.
stay like 5 minutes if you want, but I have to go after.
Oh, sure.
Yeah,
I'll stay and watch.
Cool. Sorry, what'd you say, Lauren?
Yeah, I'm gonna hang out a little bit more. I'm just sort of like,
Cool,
yeah,
cool.
I'm here.
Awesome. Okay. So, what have I done here? Oh, yeah. Let me just undo.
So if there is no rush, I'm thinking the cool part is going to be when you plug the evaluation of the position to the
Oh, yeah.
to CAD or yeah.
Yeah, this we can take this really far. I was thinking of that too. Because we can oh yeah, I was thinking cuz I want to train some AI on this, and I was thinking what's the reward function? And if the reward function is just winning the game, then that they have to play out a whole game randomly before they get any sort of reward signal. But then I was thinking, no, we can do better because we can make the reward captured pieces. So if they randomly capture the opponent's piece, then they get a reward for that. So they start learning to capture opponent's pieces, and then we can give them a very large reward if they win a game.
Yeah, and also capture pieces and not getting captured, because if you capture a pawn but they capture your queen, then it sucks. Or there is also like point to the middle of the board. There is a lot of like more subtle ways.
Mm-hmm.
I wouldn't even dare to do that myself. I think we should try to find one or at least some clues.
Yeah, well, so we need to do kind of what's called a literature review, or yeah, we should scan all the um, scan for everything that's out there. We kind of did a similar thing on one of the first labs. Remember, we just went and looked for all the CAD resources and bonding curve resources we could find.
Yeah.
I'm trying to just get. I'm trying to filter out the all the pieces that don't have any moves available. Um, I don't know why this isn't working.
Sean,
Yeah,
because it is after hours, I do have to take this moment to ask you because Sim's going to have a call with you later,
yeah.
and he's going to ask you about the ABC. Have you had a chance to dive into it any?
No, I haven't. Where should I start?
Well, similar, and it's not any different than how we began. You know, when you got into the JS file, and then you started looking at how you could actually apply in Jupyter with building the parameters in a scope that we could see. Remember? This was like what, it's like 4 months
I can
ago.
check it out here. Hello, guys. I am here.
Oh, his Sim's
Oh,
here.
we've summoned him.
We've summoned him.
I just
Awesome.
arrived now.
Perfect. Yeah, we're just kind of going after hours because we didn't make as this chess stuff keeps. I thought it'd be so easy since we found a pre-made simulation essentially to sort of deconstruct it and put it into CAD. But there's a lot of subtleties. So what we've just been doing is trying to make a function that gets all available moves for each player, because actually how this is set up, it's made to be played by humans. So at each step of the game, it has a prompt to type in what piece you want to move where. But we don't want to use a prompt. We want to just be able to find the available moves and hand them to an AI system that can just like pick one of them. So we have to make this function to like get all available moves for a player. So we've been working on that. It's a bit of a mess right now, but it's pretty fun.
I have to go. I have to go. See you guys. Hi
Thanks.
Sam and bye
Thanks,
Sam.
Tonga.
Bye.
Hey, Tonga.
See you later.
I don't.
Okay. Yeah. So Jake, were you talking about this TEC hatch?
Well, okay, is that the first one? That's the original. Okay, we have a new DAO.js that's from OneHive.
Yeah.
And
Where's that again?
It is
okay.
in one hive slash honey pot template. No, honey template. Honey dice template.
Mhm.
And
See?
the thing is that it is the one hive honeypot, which includes conviction voting and Celeste and all this stuff. We need to remove some of it because it is for the main one hive DAO and we don't need the right ID registry. But we will need, instead of the issuance app, which creates honey at a certain rate, dynamic rate, instead of that, we will have a bonding curve. So we will be adding that in this template.
Cool.
And and how it is configured, we have it in Gardens the dice template because it has to install different applications. in order to and it configures the application. So the parameters, if you want the parameters, they can be gathered at Garden template and the script of new.js. But
Gardens template, is that a different repo?
yes, because actually the first it was Gardens template, and then let's say Gardens template was the what we are doing right now at Commons. It had the bonding curve, but then OneHive just used an issuance policy instead of the bonding curve, and now Gardens will be similar to Honey with issuance and not with bonding curves. So this is why we are taking that idea and doing Commons instead of Gardens.
So the Gardens is going to stay with the idea of an issuance policy, and we're going to evolve the Gardens into Commons, which is actually going to have a bonding curve.
Exactly.
Cool.
Exactly. And we need you to work your magic on these individual things so we can start implementing like all of the necessary documentation again, and then actually creating models again and making everything we need for the ABC. And it starts right here.
And is this what Mitch has been writing blogs for, or was that Celeste maybe?
No, that was Celeste.
Okay.
But just how Celeste works with the TEC, okay? Because there's a lot of tools of Celeste that we're not using. Okay, it was just for disputable voting. But this is the whole big scope with all the issues of the ABC. It all starts right here.
The parameters of the ABC are, I don't exactly remember them. Let's see if we find them. That's for the hatch. Virtual supply, virtual balance, pressure ratio. I think that they are. Maybe they are only 3. I think that it's better if we see them in another way, because maybe I can share the screen.
Yep.
I don't know if we were finishing the lab, or is it okay that we continue?
It's entirely up to you guys. I don't mind hanging out. But this is like, yeah.
We're all just hanging out, so let's roll with this. This is awesome, and I still got the chess stuff open. We can come back to it. Maybe Lauren was so excited to see the get player functions and running through CAD, but I'll leave it open. We can just kind of flow. I'm honestly pretty much open now. I think I did have my schedule is open, I think, for the day, so I'm down to just.
Yeah, it'd be cool if we could donate some time right now and just hack this out and get going on what needs to be done for it. This would be big.
Yep.
Because as soon as Sim and them and Gabby and whatnot, and they're done, and we can get the contracts over to the auditor, we're probably maybe 30 days. 2 weeks for the auditor, 2 weeks to fix stuff, and then we need to have this ready to go. So.
Fuck yeah, let's get it.
Yeah.
Let's get that bread, that honey. Okay, guys. This is awesome. Yeah. So, what were you saying, Sam? Maybe you're gonna share your screen.
Okay. Well, we have also the marketplace app here.